Hey guys, welcome back. Magic Kid Television. It's now a different day for me. um, so, um, okay. In the last video, we saw um, rock, paper, scissors represented as a formal game. And we saw that it has no Nash equilibrium in pure strategies, although there is a Nash equilibrium in mixed strategies of basically just randomizing your choice and choosing rock, paper, scissors each a third of the time. Okay, but that's not a very interesting game, rock, paper, scissors. Um, in this final lecture, I want to look at some more interesting games, ones that maybe have some real life analogs. Okay, and perhaps the most famous example of one of these sorts of formal games is called the Prisoner's Dilemma. Okay, and let me describe to you basically what this game involves. So imagine that you are a crook, okay, and you and your accomplice have been caught trying to break into a bank, okay, and unfortunately you did not succeed. The police have caught you, and now you and your partner are both in separate interrogation rooms, and the police are basically, they're trying to get you to confess, okay. And so here's the deal that they offer you. They say, okay, you can either confess, or you can sort of keep your mouth shut. You can stay loyal to your partner. Okay. And if you stay loyal, and if your partner also stays loyal, then the police aren't going to have anything. And so, they're only going to be able to, maybe convict you guys on some sort of minor charge, some sort of misdemeanor. Okay. And you'll both get a smaller sentence. Okay. Let's say that you each get, you both would get a year of jail time. Okay. And a year of jail time actually wouldn't really be a misdemeanor. That'd be like a straight up felony, but just hypothetically, okay? So let's just say in the case that neither you or your partner rat each other out, you'll just each only get a year of jail time. Okay. Now, however, if you keep your mouth shut, but your partner decides to betray you, then we're going to offer your partner a deal. Okay. And so in that case, your accomplice will get nothing, but you will get a big sentence. You'll get 3 years of jail time. Okay. Likewise, the same is true the other way around. So if you rat out your partner, but your partner sort of naively decides to stay loyal to you and doesn't rat you out, then your partner is going to suffer. Your partner is going to get 3 years of jail time, and you're going to get away scot-free. Okay. Finally, if both partners betray each other, if you and your accomplice both betray each other, then you're going to both get 2 years of jail time. Okay. Okay. Now that might be a little bit confusing. Okay. But let's actually try playing this game together. Okay. So I want you to make a choice. There are only two strategies for each player. It's a very simple choice. You either stay loyal or you betray your partner. Okay. And you can see up in this tab up here, I've already selected my choice. Okay. So I want you to select a choice, and then I'll reveal my choice. Okay. So you select a choice right now. Either choose to stay loyal or to betray me. Okay. Have you selected a choice? Okay. You can pause the video if you want. Think about it. Okay. And then choose one of the options. Okay. All right. And then let me reveal my choice over here. Okay. So my choice is to betray. Okay. Okay. So now let's look at the payoffs. Okay. So if you chose to stay loyal, let's say you're the X player. If you chose to stay loyal, okay, then you're obviously in this uh, row here. Okay. Now, if I had stayed loyal as well, then we would be in this situation. We each get a year of jail time. But since I chose to betray, okay, well then you're going to get 3 years of jail time and I'm going to get nothing. Okay. Now, if you also chose betray, then we're going to be in this situation here, where we both get 2 years of jail time. Okay? So that's how that game works. Okay. Now, here's the thing. Why did I choose betray? Okay. Well, I want us to consider the Nash equilibrium of this game. Okay. So, and remember, Nash equilibrium consists of analyzing what the best response is for each player given what the other player plays. That's this whole mentality of game theory, right? It's like, what am I going to do? What are you going to do? And then how is that going to affect what I'm going to do? So suppose, okay, so I'm player Y. Suppose that you think that I'm going to stay loyal. Okay, you trust me. You think I'm going to stay loyal. Okay, what do you want to choose then? Well, you can see that in that situation, it's better for you to betray me. Because if you also stay loyal, we're each gonna if you also stay loyal, you're gonna get a year in prison. We're both gonna get a year. Okay. But if you betray me, you're gonna get away scotch-free. So assuming that you believe that I'm gonna stay loyal, it's best for you to betray me. Okay. Now, suppose, on the other hand, that you don't trust me and you think that I'm going to choose betray. Well, what's your best response in that case? Well, if you stay loyal and I betray you, you're going to get 3 years of jail time. But if you also betray, then you're going to get 2 years of jail time. We're both going to get 2 years of jail time. So you can see, even in this situation, even if you think I'm going to betray you, you still want to choose betray. In other words, regardless of what you think I'm going to do, it's better for you to choose betray. Okay, now that's okay. So then you can see that I've marked these stars here and here. It's always better for the first player to betray. But if you analyze it from the perspective of the second player, you'll realize that the exact same thing is true. From the second player's perspective, no matter what the first player does, it's better for the second player to choose betray. So the Nash equilibrium of this game, you can see that this cell here, betray, betray, has 2 stars. This is the Nash equilibrium of the game. Okay, so the Nash equilibrium of the prisoner's dilemma is for both prisoners, is for both convicts to betray one another. These incentives here, okay, these payoffs essentially incentivize the two agents in this game to behave or to play in that manner. Okay, now here's the thing though, and this is sort of why the prisoner's dilemma is so, it's used in a lot of different examples. So is it actually better for us collectively to betray each other? Let's look at the total jail time for both you and me in this game. If both of us betray, the total jail time served by both of us combined is 4 years. Okay? If one of us betrays but the other stays loyal, then the then the total jail time is going to be 3 years. Okay? Between the two of us. But if we both stay loyal, the total jail time is only going to be 2 years. Okay? So at some level, it's better for us to cooperate and to choose to stay loyal to each other. This one is the one that really is better for the both of us. But the incentives in the game instead bring us to this Nash equilibrium that actually has the most combined jail time. Okay. So you might be thinking, okay, that's kind of interesting, I suppose. But are there any sort of real world applications of this? And the answer is actually there are quite a few. Okay. This type of situation, okay, not this exact example, but this type of situation is a metaphor actually for many real world situations that involve some sort of choice to cooperate or to not cooperate. Okay. So I'll give you guys 3 examples. Okay. So the first example is from the National Hockey League. Okay. So here's a picture of the National Hockey League from 1979. And you can see that well, it looks a little bit surprising, okay? Because none of these players are wearing helmets. We're used to hockey players wearing those big helmets. But prior to 1979, nobody in the NHL wore helmets, okay? And now you might be thinking to yourself, well, that's kind of dumb, right? I mean, hockey, as you all know, is a very fast-paced, sort of brutal sport. People are checking each other into the walls. There's pucks flying around all over the place. Why would you not wear a helmet? And the answer is there was a little bit of a prisoner's dilemma when it came to wearing the helmets. Okay? Because think about it. So the helmets, even though they protect you from a purely competitive standpoint, they sort of impair your ability to see and hear uh, what's going on in the rink, right? So from a purely competitive standpoint, it would be better if you didn't wear a helmet. You would be better aware of your surroundings. Okay. So here's the thing. If both players decide to wear a helmet, right? Say everybody's wearing helmets. Well, then we'll all be subject to that same competitive disadvantage. So it won't really matter, right? Um, on the other hand, if only one team decides to wear a helmet and the other team decides not to wear a helmet, well, then the team that's not wearing the helmets, they're going to have a competitive edge. Okay. And finally, if neither team decides to wear a helmet, neither team is going to be safe. Okay. Well, then neither one is going to have an edge again because they'll both not be wearing helmets. Okay. But they'll both be at the increased safety risk of injuring themselves. Okay. So in other words, the sort of payoffs in this situation are very similar to the payoffs that we just saw with these criminals, right? Basically, if we both choose to cooperate, we're going to be in a better state. But if one of us chooses to cooperate, but the other decides to betray, well, then the side that decides to betray is going to have a significant advantage. Okay, so it's that same sort of mentality. And so, so for the longest time, teams in the NFL decided to not wear a helmet because, well, they figured that because they wanted to enjoy that advantage. Okay. But then since all teams were behaving that way, it ended up being that really nobody had a competitive advantage because nobody was wearing a helmet and everybody was exposed to this greater risk of injury. Okay. It took the NFL mandating the use of helmets to set the league into this state, into this, everybody is wearing helmets state, which was actually better for the players. Okay. Okay. Let's look at yet another example. So speaking of sort of sports, think about the Super Bowl. Okay. Now, you guys probably know it's very expensive to advertise during the Super Bowl, but yet companies do it. Okay. And they spend companies like Coca-Cola or Nike or Geico, they spend millions and millions of dollars every month running these expensive ads all over TV. Now, you might be thinking to yourself, well, why would they do this? Right? Because here's the thing. Let's suppose that you run a company and I run a company and we're deciding whether or not to advertise. Okay. Now, if we both don't advertise, right? Say we both um, don't advertise, then we're going to be in, oh, sorry, I think I have these flipped. My bad. Let me just fix this real quick. Okay, so the ideal situation, okay, is for both you and me to not advertise. Okay, if we both don't advertise, then neither of us will be at a disadvantage because we both won't be advertising, and we'll be able to save a lot of money not having to run those expensive ads. Okay. However, I might be sort of afraid to do that if I don't trust you. Okay. Because if I decide not to run any ads and you betray me and decide to run a lot of ads, well, then I'm going to lose all my customers. So then what ends up happening? Well, we both end up running these expensive ads, and neither of us really gets an edge because we're both running the ads. Okay? Hopefully it makes sense how that situation is similar to this helmet situation, and that's similar to this prisoner situation. Okay. Um, Now, there's one more example of this that actually has been coming up recently, which is this conflict between Saudi Arabia and Russia. Okay, so that's also an example of a prisoner's dilemma. Basically, what's going on is, Saudi Arabia and Russia can both choose to limit how much oil they produce. If they both choose to do that, then the oil price will rise and they'll both make more money. Okay. However, if Russia decides to make a lot of oil, produce a lot of oil, and Saudi Arabia decides to limit their production, okay, well then Russia is basically going to enjoy a somewhat higher price and still they'll be selling a lot of oil. Okay, so in other words, this situation where different oil-producing countries agree to limit their production of oil, it's also a prisoner's dilemma because if any country decides to break away from the agreement and actually produce a lot of oil anyway, they're going to end up making a lot more money. Okay, and so again, we have this issue of cooperation. And there's a lot of pressure essentially for these sort of cartels, these oil cartels, to break themselves up because each country within the organization has an incentive to betray the other ones by overproducing. Okay, so I hope that makes sense. Okay, that's the prisoner's dilemma. Okay, we'll just look at a few quick other examples of uh, similar types of games. Okay, so here's another one. This is an interesting one. Okay, this is called the Battle of the Sexes, and this is what's known as a coordination game. Okay, and okay, so here's how the Battle of the Sexes work. So um, okay, let's say that you are dating your significant other. Okay, and let's say that there are two events that you could go to, and let's say that those are football and opera. Okay, this is why it's called the Battle of the Sexes. Okay, so let's say that the guy in the relationship prefers to go to the football game, whereas the woman prefers to see the opera. It's like I know it's like very stereotypical, right? Um, so okay, so what are the payoffs in this situation? Well, okay, so suppose that player X is the female, okay, and so they obviously want to go to the opera more, okay. So if the two players end up both selecting the opera, okay, then player X will receive a big payoff. The girl will be very happy, and the guy, I mean, they don't like opera as much as football, but they'll still be with their significant other. So, and they don't necessarily hate opera, so they'll still be happy. They just won't be as happy as the other party. Okay. Likewise, if both the guy and the girl end up going to the football game, then the guy's going to be very happy, and the girl's going to be, they'll be satisfied. However, if one player chooses football and the other player chooses opera, or vice versa, that is to say, if they end up choosing to go to different events, then neither player will be with their partner, and neither player will be very happy. Okay. Okay, so if you consider the Nash equilibrium of this game, okay, you draw the little stars and find out where the Nash equilibrium are, you'll find that the Nash equilibria for this game, there are actually two Nash equilibria. There's one for both players to choose opera, and there's one for both players to choose football. Okay, so now ahead of time, game theory, it doesn't really let you predict which one of these scenarios will be carried out. It just tells you that you're going to be in one of these two situations, and it's very unlikely that you'll be in one of these other situations where the two players end up going to different events. So, okay, so this sort of differs slightly from the prisoner's dilemma. It's got a similar flavor to it. Okay, but here the Nash equilibrium is actually for both players to cooperate. Okay. Now, a real-world example of this involves, for example, the setting of technological standards. Okay, so um, this is a this example is it's sort of from an earlier era, but I think you guys are aware of this technology. So you guys have probably seen a VHS tape before. Okay, even though you guys are not grown up in the era where this was very popular, I'm sure you guys have seen a VHS tape. Okay, before DVDs and Blu-ray discs were popular, this is how movies were viewed at home. Now, I'm betting that none of you, though, have seen this type of tape. And to be honest, I really haven't either. This is known as a Betamax tape, okay? And it's very similar to a VHS. It's just a slightly different format. It's a slightly different technology. And actually, the Betamax format actually has a slightly better picture quality, at least according to a lot of people, than VHS, okay? Now, here's the thing. Um, there's sort of a coordination game being played here between the people who sell VHS players and the companies who produce VHS tapes. Okay? So imagine that you're a company deciding, okay, do I want to make VHS players or do I want to make Betamax players? Okay? And then suppose there's another company trying to decide, okay, do I want to manufacture VHS tapes or do I want to manufacture beta tapes? Well, it's kind of the same situation, right? Um, on the one hand, if both the suppliers of the recorders, the suppliers of the players, and the supplier of the tapes choose the same option, then you're going to be either in this situation or this situation, and both sides are going to be happy because they match. On the other hand, if all of the electronics makers decide to make VHS players, but then all the studios decide to release their movies on Betamax, well, nobody's going to be happy because nobody's going to be able to sell any of their products. Okay? So what does this incentivize? This incentivizes basically the entire world to choose one format or the other. Which one it's going to be is kind of arbitrary. Game theory doesn't tell you that. Okay, but it does tell you that everybody's going to end up going one direction or the other. And that's exactly what happened, and ended up being that VHS became the dominant format, and nobody ever has heard of Betamax anymore. Okay. There was actually a similar format wars when Blu-ray discs came out. There were actually two competing Blu-ray disc technologies, and one of them ended up being adopted. Okay, this is also true to some extent for sort of Macs versus PCs. Okay, there's a lot of examples of this kind of thing. Okay, I'm going to skip past this example, but an even earlier format war, okay, there was a movie made about this, but the choice between alternating current and direct current. I don't know how many of you know this story, but this was between Thomas Edison and Nikola Tesla. These two brilliant inventors who did their work back in the 1800s. One of them basically supported alternating current. The other one supported direct current. And there was this sort of huge format war over what kind of electrical grid the country would run. Okay. But of course, the point of this is, it's better for the country to be either all AC or all DC. If you had a mixture of both, then it would be very confusing because you would need, a different set of electronics to run on each type of current. Okay. Okay. So here's we'll talk about one last one. Okay. So this game is called Chicken. Okay. And as the name implies, it mimics this game of chicken. So how does the game of chicken work? Well, you have two people who are, I don't know, they're in some sort of vehicle. They're driving towards each other, right? And there are two options. On the one hand, you can either swerve, or on the other hand, you can sort of stay your path. You can keep going, right? Now, if both players swerve, then it's going to be fine. There's not going to be any accident. Okay. If both players choose to remain on their current path, remain straight, then, well, then obviously you're going to collide with each other and then you'll both be seriously injured. Okay, so that's not a very good outcome for either player. Now, if one player decides to swerve and the other keeps on going straight, well, then the player who swerved kind of, they look like they back down. They look, weak. And so the player who remained straight, they get like a slight bonus, right? And the other player who backed down, they get a slight negative reward. Okay. Now, okay, if we consider what the Nash equilibrium of this game is, the Nash equilibrium of this game is actually for both players to swerve. Both players to swerve. Okay? Basically because each player is going to consider the consequences of what the other one is doing and decide that it's always better to swerve regardless of what the other player does. Okay? And so okay, so this is a kind of an interesting situation, right? So what do you predict is going to happen in a game of chicken? Game theory would tell you, you predict that both players are going to back down. And this is actually what's been observed, okay? So the way the Cuban Missile Crisis was resolved, for example, was that, so the Soviet Union did back down. They removed their missiles from Cuba. But the U.S. also agreed to uh, to remove similar missiles that they had put in Italy and Turkey earlier that year. Okay, a lot of people don't know this, but the Cuban Missile Crisis. I mean, the U.S. sort of usually acts the victim in that because the Soviet Union was putting all these missiles in Cuba. But earlier that year, the U.S. had done essentially exactly the same thing and deployed similar missiles on the borders of the USSR in Italy and Turkey. Okay. Now, after some extremely tense negotiations, what happened? Both sides essentially swerved. Both sides agreed to remove their missiles from each other's neighboring territories. Okay. So, okay, that was the longest video. I know that this was a lot to digest. Okay. But hopefully that'll give you a sense of what this game theory thing is all about. It's this sort of very abstract way of representing different types of strategic situations. Okay. Now, I have for your homework, okay, I would just certainly, watch the videos, answer the little questions after each video, make sure you understand the segments. Okay, and for the homework, I want you to watch this video about the repeated prisoner's dilemma. When it turns out, when you play the prisoner's dilemma once, the Nash equilibrium, the best strategy is for both players to betray one another. But in the repeated prisoner's dilemma, where you expect to be playing the prisoner's dilemma many times over the course of many iterations and potentially with many different people all playing it with each other, it turns out that the optimal strategy in that case is quite a bit different. Okay, so watch that video. It's actually a really interesting video, and your homework will have some questions about the repeated prisoner's dilemma. Okay, that's all I got for now. So I'm going to upload this. It's a little bit late. It's going to be a little bit late because I got to basically format everything properly. But hopefully y'all will see this, and I'll see you guys in the next class, in the next assignment. Okay? All right.